Multiple spanning tree protocol is backwards compatible with 802.1d and 802.1w. Therefore, it is possible to have multiple spanning tree protocol running on various switches in your environment that are connected up to switches that are not running multiple spanning tree protocol, and they will still be able to, as a group, maintain a loop-free topology. And this is true as well if we have multiple MST regions. So if you have multiple MST regions, how do they talk together in order to make sure that they overall maintain a loop-free topology? Well, if we examine what's going on here, we can see that our IST, instance 0, is inside of our CST. Now, what is the CST? It's the common spanning tree. It's what is utilized when we are trying to group together devices that are using MST and devices that are not using MST, or different MST regions together. So the common spanning tree represents everything. So what is happening here? Well, we have the IST, instance 0. Now, it's important to realize that it's only instance 0 that's able to communicate with those switches that are not running MST. It's also only instance 0 that can communicate with other MST regions. So typically what you will do is you will design your multiple spanning tree protocol so that way there are those VLANs that do not have to communicate or be shared. That VLAN information doesn't have to be shared with switches outside of the MST region, either to legacy switches or to other MST regions. They will be mapped to their own independent spanning tree instances in multiple spanning tree protocol. So MST instance 1, MST instance 2. Every other VLAN is going to be in instance 0, and it's those VLANs and that information that can be shared with those legacy switches or shared with the other MST regions. So it's really important that you design your network appropriate based on what you're trying to accomplish. So IST instance 0 here is maintaining internally in that MST region a loop-free topology. That's what it's doing. Notice there's no loop there. On a grander scale, it is representing itself to the common spanning tree, meaning the other switches that are not running MST or other MST regions. It's representing itself as this single large switch. The single large switch. And through through IST, instance 0, it's able to exchange BPDUs with these legacy switches or the other MST regions to make sure that the common spanning tree, the overall spanning tree that we're dealing with here, made up of the different versions of spanning tree that are running, can maintain that loop-free topology overall. So if we examine this right here, it's the IST that's going to be able to send those BPDUs out to those legacy devices or those other MST regions. So if you analyze right here, it says CST, common spanning tree. Well, let's do a little bit of annotation here. Right in the middle here, this would be our IST 0. Instance 0. Let's circle that. That's our MST region. It's going to be represented to everybody else as that one large single switch to those devices that are legacy or other MST regions. And if we have some other switches here, some legacy switches, let's say, or maybe another MST region, well, overall, if we circle that, what do we have? Didn't want to drop that. Let's add that right there. All right, so what do we have overall? Well, there is our common spanning tree, or our CST, that is representing the entire physical infrastructure and spanning tree topology that is necessary to maintain that loop-free topology between the MST regions as well as other MST regions and legacy devices.